All right, let's go ahead and get started. Been off for a few days, but a few fun things going on. I got an awesome logo made for me by a buddy of mine. So I showed that at the beginning of the stream, and also reorganized my space a little bit. So I think I might be at a slight angle right now. I might need to fix my standing desk here, but hopefully it's not too distracting, and hopefully my internet is okay from here as well. Keep an eye on that. Anyway, we were doing day 17 of Advent of Code, Pyroclastic Flow, and I'm not going to go back through the whole question, but the basic idea is it's kind of like Tetris. So we have 5 types of rocks that look like this that are falling in a tall vertical chamber that's exactly 7 units wide, and they get pushed back and forth by jets to the right, to the right, to the right, to the left, and so on. That's our puzzle input. And they fall. At some point, they land, just like in Tetris. And when they land, they can pile up on one another, like so. And the question is basically asking, after the 223rd rock begins falling, how tall is the Tetris tower, basically. And so in the practice example, it's 3068, and we're looking into what it's going to be in the actual puzzle input. So let's do that. So last time, we implemented various things. We implemented the rocks themselves, which are the minus, the plus, the backwards L, the bar, and the square. And we have this simulation phase, which says, like, at what step in the little game of Tetris are we? Is there a new rock about to fall? Is a jet about to push the Tetris block one way or the other? And if so, where is the block? Is the block about to fall? And if so, where is the block? And we have our simulation itself, which knows a bunch of things about what's going on. So it knows the jet patterns, it knows how long has passed, it knows how many rocks have fallen, it knows what simulation phase we're in, it knows which rock is falling, it knows the next jet pattern index, so basically where in the vector of jet patterns we are, and it knows which squares have been occupied. And wrote up some tests in order to verify that this is working, and one of our tests is failing. Several of our tests are failing, but the simulation test is the most core one. And the thing that's failing is, we set up the simulation from the example input, and we say things like no rocks have fallen yet, like there's no falling rock, the height is 0. We step the simulation forward. Okay, now there should be one rock falling. It should be the minus rock, because that's the first rock, and its position should be it's like 2 from the left and 3 above, I think. Let's just verify that that's in fact true. Looking at the question. There we go. It appears that its left edge is 2 units away from the left wall, and its bottom edge is 3 units above the highest rock in the room. So yeah, 2, 3 is where it starts. Now we step. still one rock falling. It's been blown to the right, so we're now at 3-3 because that's the first of the jets. Then it falls to 3-2. Then it tries to get blown to the right again, but it runs into the wall. Then it falls again, and so on until it reaches 3-0, gets blown to the left, and stops because we are at we're at the point where a new rock gets created here. Whoops, that's not what I meant to click. And so one rock has still fallen. There's now no falling rock position, and we can check which squares are occupied. We can check how long has gone by. The height is now 1 because our minus rock has landed across the bottom. So this all works well. And then another rock starts falling. The place where we run into an issue, though, is not there. It is here. So we think, hey, at this point we've had the minus rock, which is 4 bits of rock, like 4 pixels basically, and a plus rock, which is like 5 pixels and a cross. So that should be 9 pixels total, and we're only getting 8 occupied squares. There should be 9, there are 8, and so what's to see here? I think this was last Thursday or something when I did this, or maybe Friday, but I think what I remember is happening is that the plus sign has basically embedded itself in the minus sign, which shouldn't happen. So 4, so 3 is the center. Was it 2, 4? Let's look at this example. Yeah, so 0, 1, 2. So we would expect x equals 2 to be, right? Oh, it comes to rest at, yes, there are 9 rocks, and it should come to rest along 0, 1, 2, 3. So x equals 3. We have 1, 2, 3. Only 3 things across x equals 3. And we would expect there to be 4. And indeed, we have 3, 0, 3, 1, 3, 2. And then we have 2, 1, and 4, 1, which isn't right because we would expect this is 2, 2. 0, 1, 2, yeah. 2, 2, 3, 2, and 4, 2 is what we want. So yeah, so the plus sign has like embedded itself accidentally. Okay. So, hypothesis is that it's not detecting landing quite right. So let's take a look at where we check the movement effect. So, movement effect down. So if we're already at 0, we stay at 0. If our positions are disjoint from occupied squares, we go ahead and update to the new position. Otherwise, we return the original position. That seems all right as long as when we call get movement effect, is after it drops. falling rock has landed. So this is just saying if we went down, would our position change or not? Falling rock has landed is true when these are equal, which means that going down by 1 didn't change our position, which is to say we've landed. That seems logical. Handle fall. If we've landed, then we turn our current rock position into occupied squares, and we set our simulation phase. Again, this seems fine. Okay. So, what do we think is the what do we think is the best way to narrow this down in a test? This is one of the things that's maybe less great about having a API like this, where we just have some like really big struct that's got a lot going on, and then we say step and it like mutates itself. It's a little bit harder to test. Because in order to test anything, you have to do all of this. But I mean, okay. It's not too bad. It's not too bad because we can instantiate it and then update the simulation phase. Yeah, let's just do it by poking at it. Okay, so let's create a new test. Let's say rock lands. Let's say let's get our simulation. And let's just update a few things about it. So let's say get occupied, or let's say occupied squares is a vector of some things, which themselves are vec2s of, let's say, 0, 1, 0, 2, 0, 3, 0, 4, and stick this in a hash set. And then we want to check, so this is a tower. Let's actually make this 3 just to this is a tower at x equals 3, and now let's say simulation.step. That should put a minus sign at some height, but maybe let's not even do that. Let's be a little more direct. Let's say simulation phase. So I'm just like poking at the internals of this thing within a test, which is actually one of the things I like about Rust's testing framework is like we have access in our tests to all of the internals of the type, which, I mean, serious test-driven development people will be like, oh, you can't do that. You should be able to test your thing using just the APIs that the thing makes public, but I find that to be a little bit too zealful. What is the word for having zeal? I don't know. Zealous. I find that to be a little overzealous. That's the word. Okay, simulation phase should be rock. What should it be? Simulation phase. Handle fall. Back to new, and we'll put it at. So it's going to be a minus. So we want it to be at like what? 3,6 we'll say, and then it'll still be falling. So we'll say simulation.step, or actually let's say assert it is not the case that simulation dot falling rock has landed, and then we'll say simulation dot, well, I guess again we can just move it ourselves. Simulation phase, and the point is that if it's at 3.5, now we're like this, we're sitting on top of the tower. Oh, which actually really should have a 0. Well, it won't matter, but just for my sanity. And here we expect it to have landed. Okay, let's start with this test. I expect it to pass, except that the other thing is busted, so I'm hoping it fails. Okay, it fails. Why are we panicking here? Okay, falling rock has not landed according to this. Cool. It was a good test because this is a really small function. So why would falling rock not have landed is a question. So the only way it doesn't land is if get movement effect and get rock position are not equal to one another. I see. I know why. Wait, do I know why? No, I don't know why. So direction is down. Potential new position is 1 below our original position. Direction is down. Y is not 0, so this doesn't happen. Else if. And now this we would expect to be false. This is the problem. Potential new position. So the point is that we want to check if the new position will overlap with the occupied squares. And if it does overlap, then we want to not move it and return the original position. If it's disjoint, though, which is the opposite of overlapping, then we want the potential new position to be the actual position. Okay. So now test rock lands, and okay, we have a passing test. And if we run all the tests, test simulate still fails. Where does it fail? Okay, so it fails in a new place. We say simulation get occupied squares should contain 2, 3. That's wrong though. That's wrong because we looked at it and it's 3, 3 that it should include. I think that was from when I misunderstood. And it should not include 2, 1 and 2, 3. What was the point? And our test is passing. Okay. So things seem to be working pretty well. Let's go ahead and, because now all we need to do in theory is just run it that many times. So let's we have step until rock lands. Let's do step until the nth rock, until before the nth rock. I mean self and usize. And here we will say for 0 through n. For in 0 through n, which we're never actually going to use, self.step until rock lands. So if I want this before the 0th time, then this is going to never run. And if I want it before the 23rd time, then it's going to run 223 times. Rock. Before the 0th rock, I'm just making sure I'm not making it off by 1 error here. So certainly if I put 0 into this, I want nothing to happen. Because before... No, that's before the first rock even. So let's say assert that n is greater than 0. Because we can't do... There is no 0th rock. Because we're 1 indexing for some reason. So then this needs to go from 0 to n minus 1. Right, because if it's before the first rock, then we want it to never run. So we want this to be 0 to 0 exclusive. Right. Okay. And now the problem itself is just what? It's just basically this, except with the actual input. And simulation simulation dot step until before the nth rock 2023, and then simulation dot get height. Before the 2023 rock begins falling. Okay. And let's see what happens. Okay, problem 17A failed. Index out of bounds. Sure, because there were only 40. Wait a second. Oh, if the end of a list is reached, it repeats. Okay, nobody told me that. So it needs to be plus equal 1. Let's just say it needs to be self dot next jet pattern index plus 1 modulo self dot jet patterns dot length, so that it goes back to 0. And fails again. But it fails in a good way because it passed the sample problem. And it's saying the answer to the actual problem is 3215. That's only a little more than the actual problem. Is that surprising? I mean, it's a little surprising. Like, how long is this whole thing? 10,000 some odd? But it's a little surprising. But it's giving an answer, and the problem is probably like the sample input. The sample input is trying to be clear, whereas the actual input can be trying to like be really careful and Tetrisy. So let's try it. 3215 is the right answer. All right. All right. Continue part 2. That wasn't too bad. The first half of the puzzle was complete. It provides 1 star. Part 2, the elephants were not impressed by your simulation. They demand to know how tall the tower will be after after a trillion rocks have stopped. Only then will they feel confident enough to proceed through the cave. In the above example, the tower would be very big. How tall will it be after it's even bigger? Interesting. Okay, so this is going to overflow everything if I try and do it naively, but I'm going to try and do it naively anyway, because that's how you want to start. So we step until right before 1 trillion and 1. Yeah. And now I'm gonna get a multiplication overflow or something. Yeah, so here's where the interesting question happens. So we need to find some simplifying assumptions. Presumably. Like, we can try and diagnose some things that are problems. So one thing that's a problem is that this hash set is going to get arbitrarily big, which we don't like. So one thing I think we want to do is only keep the highest, most occupied square in each column. Because that will determine where it falls, and otherwise this thing's getting too big. Also, stuff cycles. Let's see here. So occupied squares only needs to keep the top of each column. Actually, that's not true. That's not true, because it can run into the sides of a column. There we go. Issues. Occupied column. Occupied squares. Set is going to become way too big. Intuitively, like, we're stepping one by one, but we should be able to infer some things. The jets and the rocks are both cyclic, so at some point they'll repeat their pattern. I mean, that seems like the biggest thing. There are 10,000 jets and 5 rocks. So, roughly. So at worst, there's going to be like 50,000 unique behaviors before things repeat. So, what would that mean? That would mean we would want to simulate 50,000-ish steps, like simulate steps until both the rock pattern and the jet pattern restarted. And then we'd want to find out at what index the last, like, the question is asking for. So the question is asking for the trillion and 1th moment, which is going to be something mod our repeating number. And then we have to figure out where, then we have to do the multiplication. Does that work? I certainly believe that 50,000, like, simulating this for 50,000 shouldn't be too bad. What happens if right now I try to simulate 50,000? Let's just 50,000 just to see how long this takes. That probably takes like a second. I mean, it's not insignificant, but I mean, I don't see why it wouldn't be something like, 25 of these, like 25 seconds-ish. It's a little bit longer because this, the occupied squares set is growing over time, and so the checking for whether it's disjoint, like checking for whether it's landed yet or not, is becoming a more and more expensive operation, because the number of occupied squares is getting bigger and bigger, which I guess is this point. So we can think about speeding that up also. But still, I mean, 5 and 10,091. Do we think 10,091 is prime? It's like actually relevant. I'm guessing it is. Yep, prime. Okay, so it will be fun little bit of number theory here. In order to get a repetition of behavior, it will take, there are 5 different types of rocks, and there are 10,091, which is prime, different jets. And so it will take 50,000, it will take 5,000, or it will take 5 times 10,091, whatever that is, before the whole thing repeats itself. Wow, though, even 50,000 is slow. Okay. Let's replace this with 50,000. No, sorry, let's replace this with 5 times 10,091. Because that's what we're actually going to care about. And yeah, let's actually just think about how this is going to work. So let height before repeating be simulation.getHeight. The thing is, though, it's actually not necessarily going to, it's not going to exactly repeat. So my thought was, okay, after this many steps, the pattern's going to repeat, but it's actually not necessarily, and I imagine the puzzle input is set up this way because if you imagine you're at the top of the Tetris, you have, you now have these like crenellations, you have these different heights, and now you start again. You start a new game of Tetris. Well, now pieces fall into the floor, essentially, relative to the first time, which is going to lead to completely different, it's going to like cascade up and lead to completely different behavior. So maybe the behavior's not cyclic. Feels like at some juncture it's likely to become cyclic, though. But I guess maybe not for a really long time. Like, plausibly, it never becomes cyclic. Trillion seems like a really big number. There's got to be some way to reduce that. $1 trillion and 1. Right? 1,000, million, billion, trillion, yeah. So, what else can we do? So this is not necessarily because initial conditions after 5 times 1091 will be different. Can we find a place where it's cyclic? Maybe. I mean, we have to simulate 1 trillion is a really big number, is the main issue. So, new rock appears. Gets blown around. And it falls. Yeah, and it's not even like we can... Just thinking about, like, right now we're very letter of the law going, a jet blows in some direction, it falls 1 unit. A jet blows in the direction, it falls another unit. And so I was thinking, can we collapse those into one bigger operation that's just like, it falls, N, and it gets blown around N? The trouble with that is they don't commute, right? The falling and the getting blown around don't commute because it depends on how far you've fallen, whether you get blown to the side or you run into something. So if you imagine having like an overhang and now you're falling and you're getting blown to the left. If you fall first and go to the left, you'll miss the overhang, but if you go to the left first, you'll run into the overhang and then you fall. So that doesn't quite work. I really want to find a repeating. I want to find something that repeats. So what would that look like? What condition would need to be true in order to get some repetition? We would need some situation where where the rocks essentially made a floor. So if the rocks made a floor, then, well, if the rocks made a floor and we started off and we were on the right next rock, we were back at the minus sign, then we'd be golden. But that doesn't have to happen. Like in 50,000 different configurations. Do I think that has to happen? No. I mean, it pretty obviously doesn't have to happen. Like, let's say we just never blew all the way over to the left. It would never happen. Did I put in the example, by the way? My test, I don't think I did. So what this? Needs to be this. I assume this bombs out too. That's why we check. So, I mean, the one clear path towards optimization here is only keeping the top surface, but I don't think that's sufficient. Like, it definitely does something, but I mean, the code's gonna have to loop, 100 trillion times or something, which seems too slow. I need a way to cut this number down a lot. So after 50,000 runs, so one thing I could do is I could say for each initial set of initial conditions, solve it for 50,000. So basically, like, okay, from the floor, from the pure floor, how do you wind up after you've cycled through all of the rocks and all of the jets? Then if you have one little tower, two little towers, and so on. And any time that it repeats, I look up the previous answer and build it up that way. Okay, might be onto something here. So we can do that on demand, right? So we can start at the floor. Here's an idea. Okay, we start at the floor. We run it through the 5 rocks. No, but now we have jet patterns that are different. Basically, the idea would be to memoize, to store previous results of the simulation as a function of which rock is coming up next, what the jet patterns are. But that's gonna mean typically that's gonna mean running it 50,000 deep some number of times until there are repetitions that help us climb towards 1 trillion. I mean, that's probably faster, like, presumably sometimes it repeats. But doesn't seem super fast. Okay, one thing I want to do, let's turn occupied squares into a bit mask, which is basically just going to be a bunch of bits, because it makes it a lot easier to do collisions. And maybe we can reduce. It might also make it easy to simplify, because I'm thinking if you have a bit mask where you basically run, you count your so it's going to be a 1 or a 0. We have this Tetris game. It's 7 wide. We're going to have a 1 or a 0 as to whether or not each square is occupied, starting at the bottom row and then the next one. There are going to be circumstances, I think, where we can simplify the bit mask. Like, certainly if the bit mask it's faster than looking things up in a hash set is the main thing. Because it's really cheap to check for intersections. So let's do that. We'll say bitmask here. We'll say type bitmask is, and let's say U32 for now. Let's say U64 for now. And then anywhere that we've got occupied squares that we're like extending, we instead need to treat them as bits. Don't want to throw this in a type. Might be better. Yeah, let's actually do that. Let's define a new type. And that way we can have tests. So let's say test mask constructs. And so the idea is going to be do I think bitmask is one word or 2 words? Fascinating question. Bitmask. Google says 1 word, mostly. Yeah, Google says 1 word. Okay. And I guess new we would give it, but let's do from vex. And this should be a hash set. So let's say a vector, it'll be a vector of vectors. At the end, we will take it, stick it in an iter, and collect it, which will turn it into a set. And then this can be like, whatever, 1, 0. Let's do a simple one to start with. Let's just do 1, 0 to start with. And we'll say assert equal bitmask and bitmask new. And since that's at x equals 1, y equals 0, we would expect that to be the bitmask of 2, because 2 is binary for 1, 0. And we're going to count up. Let's do the same thing for something a little more complicated. Let's say like 2, 1 here. Desk is hitting my wall when I type. And for that we need, it's going to be 2 plus, well, 2 to the 7th plus 1. Because we're going to have a row of 7 zeros. 2 to the 7 or 2 to the 6? 7 things are flipped. 2 to the 7. So 2 to the 8th is what we want here. And 2 to the 8th is what? 256. This is 2 to the 1 plus 2 to the 8th. Okay. And honestly, that's probably a fine test. best. It's pretty hard to mess it up beyond that. And the other thing we would want, bitmask simplifies. And here's where I want to be able to basically eliminate cases where it no longer matters what's at the bottom of the bitmask. How to do that? So under what conditions can we totally ignore the fact that there was a bunch of junk down below? Well, a couple of things. One is we can't totally ignore it because we need the height at the end of the day. So we need now to track what our height was if we're going to simplify. But the point, I think, is that once you have a how do I characterize what the tower has to look like in order to get to ignore stuff down below? It's not just the topmost block in every column, because then you don't know if you go down below one of those, like say you have, in the first column you have something at 1,000, and in the second column you have something at 500. You don't know whether it's a solid wall or not below that. So I think it's that you need all of the blocks down to the minimum of the highest block in each column. Okay. Can I characterize that in terms of a bitmask? Not that easily. Not that easily. Okay. Let's hold on that then. And let's just add intersection in here. Assert bitmask is disjoint with bitmask new 0. Let's say new 1. Let's say it's not disjoint with new 2. New 3 it is disjoint with. No, new 4 it's disjoint with. New 3 it's not disjoint with, because 3 has both 1 and 2 in it. It's disjoint with, what, 255? No, it's not. It's disjoint with 255 minus 2, which is 253. It's not disjoint with 255. And it's not disjoint with 256. Something like that. And let's implement bitmask. Struct bitmask will be a U64 under the hood, I guess. I want a lot of these. I still don't think I want default. I guess I want default. Default is fine. hash, I'm not sure if I'll use it, but, and I don't care about this. Okay. Impl bitmask. We need a new function, which takes ADU64 and returns a self. We need a fromVex function, which takes a hash set of vec2s and returns a self. And it does so by saying, what? By saying, let n be vex.into_iter.map. We're going to map each of the vectors by saying, by saying 2 left shifted by 7 times y. No, sorry, 1 left shifted by that. Plus b.x. Is that right? So 0, 0. We get 1 left shifted 0 times, which is 1. That's right. And then we just sum these. And then we say self new n. Is disjoint self and other. We probably just want to say not self.intersect other. And intersects is self.intersection or intersect other does not equal 0. So actually, let's do it in the other order. Let's say this one is that it does equal 0, and this one is not self dot is disjoint other, and then intersection, or what did I say? Intersect self other. And in this case, we want a self back. Also, these are copies, so they don't need to take references. Yeah. And intersect is just ampersand. So self.0. Self other.0, and I'll go ahead and do union also. What is this issue? Union So the point is the bit mask is a bunch of 1s and 0s. The 1s and 0s map to how wide the thing is. By the way, this is a magic number. let's have this not be a magic number. Let's have this be max x. Okay. And we probably need to do this. Let's see here. Parse into try parse. Try parse. U64. Wrap. And we'll do the same thing here. Oops. Okay. And we don't like try parse, really? Try into. Oh yeah, try into. Okay, what's this? And this is a U size. So for this, we can just say as U64. Just different sizes of numbers, but we just need everything to be consistent. Okay. Good stuff. And so now, if we go back up, we just need to update all the places we used to have sets. So let's say big mask default. Let's say get occupied squares. I don't know. Do I want to even allow that anymore? Not sure I do. Because I'm going to simplify a bunch. I guess I can say as vec I guess I can just return a bit mask. And then for occupied squares, the idea here, so to get the height, the only thing I should need to do is take the leftmost bit and figure out which one it is. What's the best way to do that? I basically need the next lowest power of 2. What's the... I'm sure this is a massively solved problem. I'm pretty sure I've done this before. Obviously, you can just right shift things until you run out of things to right shift. Is there no more efficient way? can't think of a more efficient way. So let's just say self.occupied squares dot get max y. We'll say. Y plus 1. Max y. 0. Yeah, y plus 1 is right. Plus 1. And then we'll fill that in a bit. What else isn't working right? So here we need to say dot union. Get stone positions needs to be needs to return a bitmap. And that should be that. Get stone positions needs to mask. Rock position. So now this is just get relative stone positions and oh right, that's interesting. Relative stone position. Can I just left shift that many times? I think so, right? So we're not going to into it or anything. We're going to just say like dot shift rock position, and this will be bit mask from vex. Gonna rock position into it or collect. Which we'll define in a minute, and then relative stone positions is not quite going to be this. We're going to need to pipe these into stone positions as vec or as vex. We will make this not public, and then we will say get pub function get relative stone positions self bit mask self get relative stone positions as vex and bit mask from vex. Yeah. And then we just need the shift operator and whatever the other one was. But actually, think I want to do this slightly differently. So this will just be self of self.0 left shifted by n, and then here it's not quite this, it's more bitmask get shift rock position. And get shift of some position will return a U size, which will be this, this whole thing. And here we can say self get shift of whatever that was. B. Yeah, that should be a U size. Okay, that gets me a shift. And then where's my, oh, it has no problem with this. Interesting. Okay. Okay. We need to get max y also. And this will be, we'll just say let need I be 0. While let me remainder be self.0, while remainder is greater than 0, or actually not equal to 0 even. Remainder is remainder, right shifted by 1. And then we return I in the end, and do I have an off by 1 error? So if it's 0, then we want 0, which we certainly get. If it's 1, then we want 1. We want to right shift by 7 though. We want to right shift by max x. So if it's 0, we get 0. If it's let's say while remainder is greater than the limit is 1 to the max x limit. If it's equal to that, it's okay for it to be equal to that, right? So it's like this. Okay. I'm not sure it's possible we have an off by one error there, but our test should catch it. What is this? Let's just as x. Is this a thing? I guess the easier thing to do is go the other way and say bitmask of x. And oh, we should implement both length and contains, I think. That should be okay. Which, interestingly, this is pretty close to being the length function. Like if we made this length, and we made this not equal to, wait, what did I just do? Okay, length, get rid of this. We say not equal to 0. And then we say pub function get max y. And this is just no, that's not really right. It's not really right. Okay, length is a different function. So for length, we want to put function length at self returns a usize, and here we just want to say let me to return equals 0. Let me remainder equal self.0 while remainder is not equal to 0. To return is equal 1, and remainder is remainder left shifted by 1, right shifted by 1. Yep. Return to return. And I'm realizing that I didn't actually increment I. Seems important. Okay. Yes, let's implement contains. Which I imagine is just going to be most easily done by self.intersects self from vex of vec v into error correct. occupied squares now needs to be bitmask from Bex. And these no longer need to be borrowed. The rock squares are disjoint. Interesting. So now the potential new position. Wait, what are rock squares here? Yeah, so this kind of doesn't work anymore. We can't just shift relative stone positions. Because the problem is that our bitmask, the way that we're asking to shift a stone, which is comprised of multiple spots, is now to shift the bitmask, but that's just going to basically wrap the positions of the stones up to the next level when it would otherwise hit the wall. Which is the downside of doing it this way. Let's see here. So let's do assert that self dot rock would collide with wall. Rock position. And then we'll do pub function rock would collide with wall. Rock position bool. And what to say about this? Match self.rock. Oh, no, just match self. So none of them can be colliding on the left. No, actually, they even could. They even could. So if it's a minus, then we want to say that rock position dot x is less than 0, or rock position dot y. Something here. It's greater than 3 or something. This feels very iffy. This is max x minus 3 minus 4. I guess maybe in general, this is rock position dot x is greater than or equal to 0, so it is less than 0, or rock position dot x plus width plus self dot get width is greater than max x. And then we can say pub function get width, u size, and this will be four, 3, 1, and 2. Okay, I might have off by 1 error there as well. And so last couple things here. So else if this should now be rock squares any v, we just say self dot rock dot what's wrong with self dot rock? Self dot falling rock dot rock would collide with wall. B. And this is just potential new position, right? We don't need any of this. We don't need any of this. Falling rock and potential new position. Okay. And this doesn't need to be into anything. Union get stem positions. All right. Let's find out what we did wrong. Which I'm gonna presume is something. I'm gonna temporarily comment out these because they're not gonna run and they're gonna fail. And okay, test bitmap is failing. So 2, 1 should be 2 plus it's the 0th spot, so it should be the 7th spot. It's 128. Seven. Hang on a second. Is just right. (127) minus 2 is 125. 127, 128. 129, I believe is what I meant here. I believe is what I meant here. Okay, bitmask worked correctly, maybe? No, still didn't. So let's add one more thing in here, which is 0, 0, 1 when I put it into a bitmap should be, well, there should be 7 ones, so that's 2 to the 7 minus 1. So that'd be 2 to the 8. Yeah. Which is 256, which means this should be 258, which means I have to change all of these back. 256, 256 minus 2, nope, 255 minus 2, 256 minus 1, 256 on the nose, and 256 plus 1 is what that test is meant to be. This is obviously still going to fail, but I'm hoping it fails on this test instead. Bitmask 128. Yeah. Because there are 7 ones. 2 to the 7 minus 1. 7 ones. Two to the 7 is the first one. Yeah, that's right. Okay, so something's a little off about the implementation. Let's see. So from Vex, get shift so for each y we get a max x, which seems correct. For each x we get 1. So 0 comma 1 should be 1 times 7. But 7 shifts is 1 too many shifts. We need to subtract 1 off of this at the end. But if we have 0, 0, this whole thing's going to be 0. And the X test passed. Couple things. One thing is, let's assert that v dot x is greater than 0 and v dot x is less than 7. But I don't think that's ever happened, and let's call this max x. That's at 32. But then why isn't this working? Y is 1, we should get 7. 1 shifted 7 times should be 2 to the 7th. Which should be correct. Should be correct. Really? Greater than or equal to 0. Yeah, we're off by a power of 2 here. We're off by a factor of 2. So this should be, just to be clear, this should be 1, 0. Should be some number of zeros followed by 1, 0, which is 2 to the first power, which is 2. This should be one followed by 6 zeros followed by 1. No, followed by 7 zeros, because the whole bottom row is what it is. 1 followed by 7 zeros is 2 to the 7. Oh, it was 2 to the 7. It's 2 to the 8th, 28. Okay, so now that's going to pass. So in this case, whoa, boy, did I do this wrong. Let's just switch that to a 1, and this is 128, and this is 127, and these are 128. $258. One comma 1, yeah, that's right. this is 256. And okay, it's just because this is to the 7 plus 1. There we go. All right. Cool. So we've got a bit mask that represents which of our rocks are, or which of our spaces are populated. Our simulation is failing now, and it's failing because we have an off by 1 error in get height now. Yeah, that's not gonna work. So get max y. Yeah, so I think the point needs to be that if self.occupied squares is is 0, then the height is 0. Okay, and apparently we're trying to collide our rock with the wall at a time when we've said we're not allowed to. Let's see here. Go backtrace. Okay. So here, direction is down. Falling rock, get stone position. Yeah, okay, so we just want to move this check up. So let's take all of this. So if falling rock would collide with the wall, then we don't worry about it. We just return. And otherwise we can get the rock squares. Check if they're disjoint and return. If self.occupied, so if falling rock has landed, then we get the current occupied squares. And we union them. function is messed up? Probably. Fails immediately. And why is that? So we take our number and we count how many times we have to right shift it. If we have to right shift it 0 times, then we're done. No, this isn't right at all. We have to count whether or not the thing that we're right shifting is remainder plus equals remainder and 1. Something like that anyway. What's going on here? We can just silently cast this to a usize. Okay. Problem A is trying to overflow. Yeah. That's not good. So the issue now is that the U32 or the U64 is too small. Because there's only 64 bits in there. Hey Cowcuz, thanks for following. So I have to wind up in a minute, but I guess this bit mask thing might end up being a little tricky. So 64 bits though should go a long way. If we think that the top of the tower is never going to get more than like something like 8 deep. I don't believe that that's true though. That's disappointing. Keep up the good work, man. Thanks. Appreciate it. Yeah. So we have to reverse back to hash maps, which I don't love. I mean, I can create a bigger bit mask. Like, we can just use a whole bunch of U64s. Alright, well, I think I'm going to wrap up here for now. Because I think this is going to be a bit of a moment. Gonna have to figure out what to do about this overflow. And then I'm still not sure. I still have this idea that I want to use cyclic. Like, I want to use the fact that once we've computed the flow, the effect of the jets in a certain situation, we should be able to reuse that computation. I haven't quite worked out what the right way to apply that is, but I think that's going to be the name of the game for next time. So anyway, gonna wrap up here. Thanks for watching. Please like and follow if you haven't already. Appreciate the awesome new logo that my friend created for me. And I will catch you all soon. I'm not going to be here on Thursday. Have a family thing, but maybe I'll try to do tomorrow and Friday instead, something like that. So, all right, take care, guys.